welcome you. Good evening, and let's start without much wasting more time. Yeah, so I'll share my screen as well so that you can see the agenda today. Yeah, so we are going to discuss quite a lot of things, and mostly we will stick to what we had decided in the group. So that's another reason that if you are not in my group, please ensure that you join them. Yeah, so I have given you the WhatsApp number. You can join there. So this is the third lesson in the series. Yeah, I have conducted many webinars, but then this is the third in the series where we decided to learn a few things. Yeah, so let's focus on the agenda first. We are going to have learning as usual. Yeah, and then there will be a special offer based on certain popular demand, and there will be a Q&A as we discussed. And finally, there will be a challenge. So wait for this. The winners are going to be specially rewarded, and that's going to be an interesting challenge. Yeah, you can develop your skills uh, based on the challenge as well. Yeah, so wait till the end. This will be towards the end of the webinar. Stay tuned. You are going to learn quite a lot of things. So without wasting time, let's first focus on structural scheme, its advantages. What do you mean by structural scheme? Some of you may be uh, 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 good at it. Some of you may be struggling with that. Some of you may be thinking, is it really required to have a great structural scheme? What do you mean by that? So many questions you might have. So those who are really thorough in scheming a building, say yes. Those who are very much confused, say no. So let me see how many of you are very much versatile in scheming a building. What you mean by scheming, how to go about that, how to orient columns, everything. Yeah, so a lot of no. Yeah, type in your answers so that I understand the people who don't know. Yeah, so it's important for me to know what all topics I need to cover. Parikshit says MTech. Yeah, good. So if you enable yourself to do all these by the time you pass out, it's going to be great. Okay, Parth says yes. Yeah, some of you know it, some of you are new to it. Anyway, so let's first discuss what do you mean scheme. Yeah, it's the arrangement of the structural members. Yeah, there can be more scheme for a building. Yeah, you need to decide your slab thickness, you need to decide your beam positions, you need to decide your sizes, you need to position your columns, orient the columns, size the columns. You need to decide if a shear wall is needed or not. What is the lateral load resisting mechanism? Is it a single system? Is it a dual system? Position of shear walls and so on. Yeah, so all of this put together is a structural scheme. Okay, now some of it for smaller buildings comes with experience. You can do trial and error and arrive at that. Some of it needs more detailed study. Yeah, I'm going to give you certain rules that are going to help you to speed up some of these steps. Yeah, we cannot completely do or develop entire skills, but then I'm going to give you skill sets or tips that are going to let you explore this on your own, ask questions, and then further take it forward. Okay, so before getting into scheme, let me also tell you something about 1893, 2016, which talks about regular and irregular configurations. Yeah, so below points will reduce damage during earthquakes. So the main primary aim of a building scheme, good scheme, is not just gravity loads, it's also about um, lateral resistance. Yeah. So buildings with simple and regular geometry is going to perform better. Yeah. It's not that you cannot have complicated geometry. It's not that you have to deny a client of what he wants. Yeah. But then regular geometry will, rectangularish geometry will perform better. Uniformly distributed mass in plan and height. That is, you should distribute your services, your stair, your heavily loaded things equally in the floor. Not like one place you have a lot of concentrated loads, and in another place the loads are very less. Don't do that. In the group, somebody had put a doubt today saying that he's getting tension in one of the columns. Is it because that there is no much load in one side? Yeah, try to distribute it. It's an architectural and client's responsibility, but then you are the person who need to advise them. Yes, you need to know that. Uniformly distributed stiffness and height, avoid irregularity, and avoid cantilevers. Again, I'm not saying you deny everything that a client wants. That's not the idea. After all, a client is not building things to see structural behavior. Yeah, it's not for that. He's building something. He's building to enjoy the building, right? He needs to use the building. So we need to facilitate that. But then there are certain things that we cannot allow, or we need to demand. Yeah, so we need to educate them. So avoiding cantilever unnecessarily. Yeah, if there is a real requirement, yes, we may have to give it, but otherwise you need to advise and remove them. Okay, so this is a one single sheet which will explain you. It's a cheat sheet. If you want, you can later ask in the group. I can share this with you. I might have done that in the past. Yeah, point one, avoid irregularity. So what do you mean by that? Geometric irregularity. It should be rectangular, symmetric. All this will help you in having a great performance. I will show you certain things which will allow you to understand this more. Uniform mass, as I told you, it should be distributed. Here some library, here some lightweight things. If you distribute it in that way, you can end up in irregularity. Yeah, uniform stiffness. Say if you put large columns here and small columns in other place, shear wall in a corner, all this can result in ununiform, non-uniform stiffness distribution that can create problems. Yeah, then your building should have some initial strength, adequate member sizes, some initial stiffness and ductility. Now, who can tell me what is ductility? Or tell me, is as say any engineers get confused at that point, especially if you are a MTech holder and if somebody asks you in an interview, or if you are a BTech holder and aspiring to be a structural consultant and go for an interview and straight away somebody asks you, is elasticity and ductility same? What's your answer? Yes or no? Tell me. Yes or no? Then differentiate that. What is the difference? Yeah, ductility is that aspect of material behavior which allows it to deform without rupture. Yeah, so it allows a building to reduce the number of cracks during earthquake. Okay, so that's the main advantage of ductility. So you need to ensure your building is ductile. And point three is, so point one is about regularity and having good behavior because of that. Second is about having better performance by achieving this. And third is right sizing and orientation of all that which I told you. Yeah, so these 3 points are very important for building structural scheme. Okay, now why do we do all this? I will come to that. Yeah, what are the advantages of having a great scheme, which is very important. Okay, so here again, I'm representing it in a picture format with a bit more explanation. You can ask me this if you want to. The larger explanation of these points which I mentioned is there in this cheat sheet. Yeah, so you can ask me if you want that in the group or in WhatsApp. I will share this with you. Okay, this cheat sheets I'm going to share with you. So if you have maybe very quickly we'll run through the summary. So what you need to avoid is L-shaped buildings. If you have L-shaped buildings, split it with joints. Yeah, say if you have in plan L-shaped building, split it with joints so that they are two different structurally. So that's how you make things regular. Uh, then if you have uniform non-uniform mass in your building, you need to avoid that. So spread the loads across. If you have secondary structures and all that, storage and all that, spread that across. Stiffness, again, as I told you, lift and all that should not be in a corner. I've already told you that. Yeah, so these are things that you need to have in order to achieve good performance of a building. Now, how do you size slabs? If you have done my free course, I have mentioned in that particular course how to size a slab. That's what I remember. If not, you can ask me. I can share you certain things. How to size slabs, beams and columns. You can size it by trial and error if you know how to analyze and use ETABS. That's the better method. Yeah, so you need to know how to size slabs and beams, columns, shear walls. Yeah, this is slightly advanced. Maybe if you're a beginner, it will be a little challenging for you. Other things you can learn faster. And what is the role of a structural slab in a building? Many of us think that slab is a secondary member, but then it also has a diaphragm action. It's tying the entire building together. Yeah. So it allows the lateral load path in a building. So that's why if you have heard people saying, yeah, avoid large openings in slabs. What is the problem with large openings in a slab? That will create irregularity. It will create a lot of problems. There will be discontinuity in the load path. Yeah, so if this is your floor plan, your vertical members are tied together by the slab. Yeah, so it acts as a diaphragm. It's like a rigid um, member in these planes, in the horizontal plane. So it's tying the entire building together. It has a great role in ensuring the building is performing better. Now, if you have a large cutout like this in the corner of a building, that is undesirable. Yeah, that's going to create a lot of problems in your building, irregularity in your building. Okay, so you need to be mindful about that. So slabs are not just some element, it's having its own significance. So you need to know how to size that. Architects decides the functional space and slab locations, but then we need to educate them to avoid large openings, especially at the edges. So if you are a structural engineer, if you are early in the project, and if you are in the design coordination stage, design development stage rather, you should be able to propose cutout locations and all that, which are fairly okay. Okay. And when it comes to role of a beam, or how do you decide beam positions? Basically, there are three rules I can give you for deciding beam locations. Who can tell me how do you decide beam locations? There are three basic purpose for beams. Yeah, one is to split a slab into manageable thickness. Okay, say if you have a very large slab, 4 meter or 5 meter by 7 meter, what is the problem? The slab thickness will be very large. Okay, so if your slab is very large, its thickness is also going to be large, right? So if the thickness is also large, what happens? The gravity, the weight of the building will increase. If the weight of the building increase, the seismic forces also will increase. So everything is bad if your slab thickness is very much higher. So first rule, to divide the slab into manageable thickness. Yeah, 120, 100, 150, that kind of thickness we need in the for the slabs. Yeah, so in order to achieve that, we give beams. That's one role of your beam. What is the second role of your beam? You generally give a beam under a wall. Yeah, so if you have a 200 thick wall on the slab, I would prefer, yeah, sometimes you may have to avoid, but then I might prefer to give that beam over there. So if there was no wall, I would have given that beam exactly at the center to divide the slab into two. But say um, the wall is slightly away here, then maybe I would like to have my beam under that so that the wall is directly on that beam rather than uh, I don't want to give the beam over here. Yeah. So slightly I'm moving that beam. So that decision you are taking because of the presence of the wall. So one slab may be slightly larger, the other one may be slightly smaller. Yeah. So that's one second rule. And the third rule is to tie the columns. Yeah. You need to tie the columns in order to ensure that there is a load path as well as the columns are not very much slender. Of course, the slabs also perform the tie action, but then I would prefer to have a beam tying the columns. So three rules for deciding the location of beams: uh, to divide the slabs into manageable thickness. Second is to support the walls in the building. And third is to tie the columns. So wherever there are columns, you tie them with um, beams. Yeah, so these are the three primary role of a beam. So you manage these three. See, in a real building, you will have all the three together. So you need to be able to manage that, decide that based on these three requirement. Yeah, so these are tips, but you need to apply it by doing real projects. Okay, so Column location, there are many parameters, architectural things, structural things. Yeah. A very rough rule. Ensure that if it's a smaller building, ensure that your beam spans are not very large. So at every 6 meters, if it's an apartment, or if it's a small space, yeah, if it's more than 6 meters, you may end up with larger beam and column sizes. So ensure, again, it's a rough rule, okay? It's not a mandatory every time rule. It's a rough rule. Your soil type also decides spacing. If your soil is very poor, you cannot afford to have very large concentrated loads. So maybe if you have a building near a coastal area where N values are very poor, yeah, then you may have to have 3 meter spacing for your columns, 2.5 meters sometimes, depending. I mean, it's not all the time, depending upon the kind of the building. Yeah, so soil type also decides your column positions, not just your functional plan. Your building shape requires careful attention. Yeah, one example. Uh, Say if you have a building, you can see my screen, right? Yeah. Say if you have a building of this shape, yeah, something like this or symmetric to it. Say you may need a column here, you may need a column here, you may need a column here, you may need a column here. Say this is 3 meter, this is a 1 meter. You may need a column here. Now, if uh, architect can allow you a beam here, maybe this column you can avoid, or maybe you can keep this and avoid this. Yeah, it depends. Maybe he can convert this into a pergola. It's an open space. Yeah, so all this you need to discuss. You have to have some idea about architectural and other requirements so that you can propose this. Yeah, so as a structural engineer, you also need to understand architecture in order to propose certain things. Yeah, same way architects also should have some understanding so that they can decide a few things on structures as well. So that's how it needs to be developed. And with the coming of AI, you have a clear edge over architects in leading a project, provided you are good at multi-D understanding and using leveraging AI. Yeah, so focus on that. You please go and see my webinar on AI if you have not. Yeah, so how many of you have seen that webinar already? Those who live attended, please tell me you did. Those who have not, please tell me no. How many of you attended my webinar on AI live? Say yes. Those who have not attended, say no, so that I know how many of you have previously attended my webinar. So most of you are saying no. Then please go ahead and watch Civilera YouTube channel. I have put in there. Alternatively, you can ask in the group or you can message me. I will share you. I had in fact done 2 webinars on AI. Both were similar, but then it was done. Srinivasan is asking, share it. Please ask me on group or in WhatsApp. I have shared you my number. If you want the number again, I'm sharing it again. Uh, you can WhatsApp me. I will share you the group number, group link, and the webinar as well. Okay. You can leave a message into this. Maybe I will, or somebody would respond late today or tomorrow. Yeah, I'm not sure when I will, depending upon the numbers, we will respond to that. But we will respond. Okay, so column location, I gave you certain ideas. Column shape, generally rectangular or square, but there can be situations where you need L columns, sometimes even other shaped columns. Okay, so I can share you these slides for your understanding if you want to. You can ask me that also. Column orientation. So let me just quickly have a word on column orientation and then discuss more things. Yeah, I'm skipping some less significant things that you can understand from the cheat sheets and everything that I'm going to share with you. Okay, so the column orientation. So assume that you have building like this. Say this is 40 meters and say this is 20 meters or say 15 meters. Okay, let the number of floors be 5 or 10, whatever it is. Or let's make this, okay, this is 15 meters. Now, the idea is, or let us do one thing, let's make this like a one room for easy explanation. So let this be 7 meters and let this be 3 meters or 4 meters. Now there are two aspects. One is gravity loads. Second is seismic and all that, the lateral loads. Now, if you look at the gravity load point of view, this would be the orientation preferred. Okay. What is the reason? Because in this direction, you have larger frames. Okay. So now if your columns are oriented like this, it will have better capacity. Why? See, how is the column going to have the bending? It's from the beam. So the beam is having this bending, which means under gravity I'm talking about. When this is having a bending, it's the column which is resisting that. It's a frame, right? It's all framed together. It's not simply supported. They are connected together. They are monolithic and behaves together. So there is a frame action. Okay, so more the inertia for this, the better. What is inertia? BD cube by 12. Okay, so this more in that direction of bending is better. So here the spans are more. So it's oriented like this. But then please know that when the building is narrow, seismic point of view, this will have more criticality in this direction probably. Why? You think about a table or something you are pushing and trying to overturn. Yeah. When the width is less towards that direction, it will fall faster. In the longer direction, it will not fall because it's having more stability in that direction. So seismic point of view, maybe that you will need it in this manner. So how do you go about that? Yeah. So if you're confused, what you could do is for your initial position and orientation, go with your gravity rules. Okay. Later on, do your analysis, understand the deflections, lateral deflections, and decide based on your analysis results. You can decide if you want to reorient it, things like that. Yeah. But certain things with experience, you will be able to judge it very fast and very easily. But then certain things you will have to do your analysis and then arrive at your um, um final orientation. Yeah. Okay. When you have multiple frames and multiple floors, it might be a little challenging for beginners, but then this is a rough rule. Yeah, more of it. Start doing it. Ask me doubts in the group. Wherever time allows, I will share that. And there will be more people also who are my students are there. There are other engineers. Somebody or the other will start the discussion and you can learn in that way also. Yeah, so this is one little rule for deciding the column orientation. Yeah, I'm moving. There are more things in that, but then I'm giving you an idea on what you need to be doing based on gravity load and based on seismic load. You need to decide your column orientation. Now tell me, what are the benefits of doing this? Yeah, benefits of doing a proper, very great scheme. You might have had challenges from clients and architects. I want to remove these columns. Less number of columns are better. How many of you have heard this? Less number of columns are better. It is more economic. How many of you have heard this? And how many of you believe this? Say yes if you have heard this. How many of you have heard this from an architect or from a client or from somebody that less number of columns are more economic? Yeah, so there are a few yes. Akshada says yes. Okay. Parikshit says, but it's not safe. Yeah. So less is not great. More is also not great. The optimum. Yeah, that's where you need to be able to uh, get into. Yeah. So you should be that engineer who is going to give optimum design, not more, not less. Yeah. So that's where you have to be. All right. So there is an optimum for everything. Less is not great. Yeah. Because if you are having less columns, maybe your footings are going to be larger in size. Maybe that your building is going to have less alternate load paths. So there are going to be a lot of challenges if the numbers are less. Yeah. It's not that it's going to be more economic. It's going to be a compromised building if it is economic. Yeah. So it can never be economic if you are rightly designing with less number of columns than needed. Okay. But then sometimes what is needed by the client may have to be provided, but then you need to ensure that that is safe, in which case you have to design it for that, which means your cost is going to be up. Yeah, that's but not your problem. That happens at times. Yeah, but there are going to be challenging requirements. You need to meet that. Okay, so what are the advantages of having a great scheme? Yeah, so that's what we are going to very quickly explain. And if you are able to convey this to your clients in the right way, even architects, they are going to accept that. Yeah, many times the way that you convey, yeah, you are rigid and you are trying to demand things. Yeah, you need to be able to influence them. Yeah, those who are wanting that. Okay, one is that better performance. What is better performance? What do you mean by better performance? Yeah, I will show you some better performance in some time. But we discussed about non, what do you call, irregularity. Yeah, avoiding irregularity. So that will allow some better performance of your building in the event of earthquake. And second thing is alternate load path. I will come to that. And third is easy to manage design. Yeah, your later life in your design, as in, say, you started your scheming, try to get the perfect scheme. Yeah, then later on you will not struggle. You means the entire design team, you and the other architects and everybody together. You will not have to say struggle to make things work. Yeah, by doing, redoing, yeah, testing, looking at the stiffness distribution, changing that, playing around with the structure and changing the stiffness center and so on. Yeah, so you will not have to do a lot of work in order to manage. Yeah, so you will save time, you will coordinate better, you will get more performing building. Okay. So, what do you mean by alternate load path? Yeah, I always tell this because it's a very important thing. Say, for example, uh, say you have, how many of you have understood this clearly? How many of you have heard me talking about alternate load path before? Tell me yes if you have heard me talking, no if you have not. Let me know how many of you are repeat attenders of my webinars. Say yes if you know about it. Okay, so many yes, some no, many no's. Okay, Jerin is my student, so and that too DCTS, right? So you of course would have heard me talking about that many times. Okay, so let me tell you what is alternate load path. Now assume you have a building or say a small room. Yeah, this also increase your confidence if you do a proper engineering. Okay, that's one thing. Second thing is it's very important for you to understand this so that you can influence others also. Say architect and client said I want only 4 columns, it's a small room. Now the problem here is, say this is 7 meters, say, due to whatever reasons, if one column fails, yeah, say this column is gone, whatever reason, let it be a blast, accident, mistake, design mistake, construction mistake, whatever, one column is gone. Now, what is the best possibility that the structure will not fall immediately? Very less possibility. Why? Say this is 5 meters. Because if this has to stand, this one column needs to stand like a cantilever, taking this point load also. Yeah. How many meters? 5 meter. Very rare chance. Yeah. Very rare chance. But then, had you got one column here breaking the 7 meters, even if one of the column goes, you need to cantilever only 3 meters, 3.5 meters. Yeah. And also it's a it's having a back anchorage. Yeah. That is likely to stand. Why? Because say you would have designed this for seismic everything. Yeah. So your detailing would have been something like this. Okay. You have extra bars here. You have extra bars here. This column went off. Now it's cantilevering 3.5 meters. Okay. 3.5 looks very large. But then the fact is, you have done this for seismic, you have done this for wind, and all the more you will have 1.5 or 1.2, whatever your factor of safety for this. Okay. Even under gravity, you have a 1.5 factor of safety, which means it can take 50% load more. And your live loads are generally very high. You will not have that kind of live load. Okay, so when this column fails, you are only having unfactored gravity load, actual. There is no seismic. Yeah, say an accident happened. So at that point, there is no seismic, right? It's just a accident. Column failed, maybe a blast, or maybe a construction mistake. It is cracking. Okay. Now you have already designed for seismic, but seismic is not acting, so you can use that rebar available there. And your factor of safety is not needed now because you are not having that overload. Dead load also is not overloaded. Yeah, it's the right amount of load here. Maybe live load will be less because people are going to be evacuated. So this steel here provided will bridge that failure. Yeah, it's having an alternate load path. The actual load path would have been load going half here, but then right now this is gone. Now the load path changed to this cantilever. More loads are going here, but then all these are designed for factor of safety as well as seismic and other combinations. Yeah, so it has that capacity to take or act as a cantilever. Okay, so if you have checked this prior to your execution and then provided the scheme in a way that you bridge all this, then your building will never have disastrous collapses. Yes. See, now you should not ask me, what if this column and this column fails at the same time? That's a very rare chance, right? The probability is very less. If that happens, your building might fall down. We cannot we cannot take care of every column failing at the same time. Yeah, we are not magicians. Yeah, but then one member failing at a time, you should be able to take care of that. Same way beams. Assume that you gave same way. This is um, um 7 meter by 5 meter slab. Okay. Now, if you don't give any secondary members, what happens? If something happens to any of one of the beam, then the chance of the slab remaining there may be lesser. But then if you have one here, maybe that this was designed as a two-way slab. Yeah, if this beam fails, it can still span as a one-way slab here, applying the same principles. Yeah, because live load is less, factor safety is there. It might be able to span as a one-way slab, provided your detailing is proper. Yeah. So this is one of the many reasons that a non-engineered building is sometimes not failing, it's standing, because without the Maestri's knowledge, a lot of alternate load paths are automatically coming in. Yeah. Without your knowledge, a lot of load path already exist. So now think about you applying that mind and then scheming. Yeah, what will be the result? Your building will perform wonderfully. Yeah. So apply your mind. Even if you are an experienced structural engineer, from tomorrow, start doing this. That is, say you produce your drawing. Okay. Say your final layout is ready. Okay. Everything you are going to issue this to site. Spend half an hour. Okay. What happens? Identify some key members in your building. Identify some key members, as in, if that member fails, can more than 25% of the building fail? Just take a look. So first see if this beam fails, or start from columns. If this column fail, will more than 25% of the building fail? Then it's a disaster. Yeah. Attend to that by providing additional columns. Same way, if one beam is removed, say this beam fails, can now this slab act as a one-way slab? Or can it act as a two-way slab like this just by the removal of one beam? Might be possible because, say, this is 3 meter, or say 2 meter, 2 meter. Now, without this beam, that becomes 4 meter. This is 3 meter. Maybe still you have only 8 or 200 requirement. So removing this beam, still that slab might be standing there for unfactored moment. Yeah. So that way, identify some key members, remove one at a time, and check for possibility of that building standing. 75% should stand at least. Yeah, otherwise it is going to be a disproportionate collapse, or a large area will collapse. Yeah, so after your final drawing is made, you can make this quick checks only for gravity unfactored loads. Yeah, if it stands well and good, your scheme is perfect. Yeah, so that way you can be more confident also on your design. Nothing would happen to your building. Worst case is some crack formation and redistribution. Yeah, so employ that in your building. And if you are able to convince your client saying that this is why I'm doing it, yeah, this is the reason for that. Yeah, if you do it without much additional cost, minor additional costs, maybe that you will be able to meet that. So here, the only change that you might have to do is, when you had this beam, maybe that you had detailed your slab like one bar going here as cut bars. Okay, now when that slab has to stand without this beam here, maybe that you will have to give that bar continuous. Yeah, like this. So that's a minor cost increase. Okay, so if you take care like this, your building will have a lot of bridgeability. Yeah, you will not end up. So depending upon the importance of your building, you need to decide how many checks you need to do. If it's a small building where you don't expect any kind of accident, leave that. Okay, so that's one tip, or that advantage that you're going to get with a great scheme. All right. Now coming back to the presentation. Uh, okay, so let me also show you one more thing, better performance. Okay. Again, I might have shown this in the previous webinar also, but then let me show you for the new comers here. Say this is one of the project that I do for the current batch of DCTS students. Let me take the plan. Let me show you a few things. Give me a second. This is the ETABS model of that, analytical model of that. This is the scheme. Yeah, I'm not saying this is a perfect scheme. There are shortcomings in this. Can you tell me, anybody, tell me, what is the shortcoming? What can be the shortcoming in this? Type and give me the answer based on whatever I told you so far. What can be a shortcoming in this particular scheme? What do you think can, just don't say shear wall. What shear wall? And I think Michael is also my student. Yeah. Beam not connected to column. Beams are connected to column, Pavan. Lift at end. Vivekanand then says lift at end. So what happens if the lift is at end? Location of shear wall. Parth is saying location of shear wall. Anyone else? Shear wall will cause irregularity. Opening. Ravi, who said, oh, Somil is saying large opening. No, this is not a large opening. This is a normal opening. This is a stair. Shear wall should be at center. Yeah. You can compensate that. Even if you have a shear wall here, you can manage that with other additional walls, but then that becomes a little challenging for this kind of building. Okay. So let me show you that. I have analyzed this. I've done a dynamic analysis for this. Okay. Already done. I'm not showing you how to do the dynamic analysis. It's already done. Now I'm going to show you the mode shapes. Yeah. So I'm going to animate this. Give me and apply. So it's going to show the mode shape here. This is the first mode of vibration. That is when the earthquake occurs. This is how it is going to, in a simple way, I'm telling you, this is going to be the first way in which this building is going to move, the first mode of vibration. So let me animate that. It's taking a little time. So this is a little torsion and a little translation in y direction. So that is the movement. Yeah. How do you exactly check how much mass participation, how much is torsion, all that? There are options here. So those who are familiar with ETABS and dynamic analysis would know that. Others, you need to learn it really well in order to understand that. But then you can make out from your model mass ratios, if you go to the table, what I showed you was the graphical representation. Now here, if you go, you will be able to find out the mass participation by seeing this. You can see here that y direction it has 52% and torsion is 28. Yeah, so 52. Predominantly it is y direction translation, but you also have torsion. Now, if you look at the third mode, um, you have 21 y and quite a lot of torsion. See, 46 is torsion. So let me show you that also graphically. So let me go to the second mode first and then animate. So that's a pure X direction translation. Yeah. Now, why are these important for those who are new? See, earthquake is for a little time. Okay. So how the building is going to move in the initial modes are very important, because if your building is moving in a translation direction, in X and Y direction, it is good, because if it goes into torsional modes in the initial stages, your building is going to experience a lot of brittle forces. Yeah, torsion will induce a lot of tension in your building and it can fail very quickly. Rapid failure will happen, disproportionate collapse can happen. Yeah, and people will not get time to evacuate. So if you avoid initial modes coming in torsion, it's good for the building. Yeah, so your scheme should be in a way that when the earthquake starts initially, uh, your building should not experience torsion. Yeah, so that's what we are ensuring by doing a good scheme and saying that torsion should be avoided. All that means this. Okay, now if you look at the third mode, um, that's a pure torsion. Yeah, a lot of torsion. So you need to try to avoid this. And for avoiding that, you may have to redo certain scheming things. Yeah, you may have to move this to another location or balance it with additional stiffness in the other end, all that stuff. There are many more things to be experimented and done in order to get rid of torsion. Okay. And if you want to know this more clearly, those who are experienced, and if you don't know, I can just share you one more tip. See, when you come to analyze and when you look at the set load cases to run, here there is a button, calculate diaphragm centers of rigidity. This is for those who have some experience. Okay, if you don't know about this, those who are beginners, you will not be using this straight away. If you click this button and then analyze it, I've already done that, and then go to display and show tables, and then come to structural output, and then come to uh, other output in items. Here there is something called centers of mass and rigidity. Yeah, click on that and click on OK. It will display the center of, you can see here, it's displaying the center of mass, and it is also displaying the center of stiffness. So you can see how far it is and make the corrective uh, action if needed. Yeah, so that allows you, see, there is a lot of difference between center of mass and the rigidity, whereas in y direction it's more. So the x direction, it's not mass center, and your stiffness center is not um, near. That's the reason there is torsion in the initial modes, whereas in the other direction it's more closer. All this you can check by enabling that particular option. So how many of you knew about this, seniors, those who are saying you are consultants? Did you know about that option? Yes, if you knew it. No, if you didn't know about that. Type in. Just want to understand your experience level. Based on that, I can suggest and take up topics in the next webinars. That's the reason I'm asking you. So tell me if you knew about this. Yes, Vivekanand and similar consultants. Parth, knew about that or not? Yes for yes, no for if you didn't know about that. Nobody? Say yes or no. No, says Akshada. Yognath says yes. Great. Satyajit says no. Okay, there's a mix of everything. Anyway, that's how you look at that. Now, coming back to our planned things. Let me have an eye on the time. Okay. So that's all I plan to talk. Yeah, I will give you more chance to discuss and also take up some of the questions that you had asked in the groups and in the community, in the learning community, if you were my student. So now how do you learn or continue learning? One is similar webinars. Maybe other people are also conducting. I'm conducting. You can use the group. I cannot be responding all the time. Okay. Whenever I'm able to, I will respond. Sometimes I will ask you to put it in the other group so that I can see it later, and you will have to give me full information in order to answer. Yeah. Sometimes I don't answer because the information asked is partial. Yeah. So you will have to ask in a complete manner. Yeah. Now, in case if you want to speed up your learning through the programs that I have, here is an offer. Once more, I'm giving you based on the popular demand. This time I cannot give you unlimited. For 10 people, I'm giving you that course, ETABS course. Yeah. For a discounted pricing. And I will also give you that same offer last webinar I gave you only for 10 students this time. So that moment we hit 10 numbers, we are going to close that. Okay, so I'm sharing that link with you in the webinar chat. If you want this directly, you can message me on the number that I gave you. Okay, so this offer you can take. Yeah, you will get a CAD course free along with that, where it will teach you to detail all inclined beams, everything, how you need to do, what are the code provision for detailing. Some interesting members are also discussed in that. Yeah, less of CAD, more of detailing rules. You will get that. So in case if you want that, you can bag it and message me or message in the group asking for the extra bonus. Okay, extra bonus is an additional course 499. Yes, if you are taking this, you are getting the ETABS course for hardly 8,000 rupees. Yeah, plus an additional course on um, AutoCAD detailing. Yeah, it's focusing more on detailing, less on AutoCAD. With minimal commands, you will be able to do the detailing works. Yeah, primarily this ETABS course is going to focus on entire design of mid-rise buildings. So those who are interested can take that immediately. 10 numbers we have set it. And those who want the link directly, you can message me after the webinar. I can give you. And my vision, as always, I told you, it is to enable engineers. Of course, this is a business vertical that I have, but then the broader idea is to enable engineers to have a great learning. Yeah. So this is a message that I got from my DCTS students a couple of days back. Yeah. So I'm just sharing with you. If it motivates you, uh, you can read and understand. Yeah. She got into Bureau Happold in Hyderabad. And this is after the program. And I also want to say that if there are women engineers with a lot of break, please get inspiration, enable yourself, learn well, and get into good roles, because your participation is very much required for the nation as well. Yeah, 50% of community, if you are not working, there is no progress. Yeah. So we all need to contribute. So if you are a structural engineer, MTech, and idle at home, think about learning things. Yeah, because see, if Danya can do it, you can also do it. So she works for one of the largest, one of the best company now. Yeah, she's having a little apprehension, but then she's confirmed now. She has uh, overcome the probation period and all that, and is a permanent staff now in Bureau Happold, Hyderabad. Yeah, so learn well, whatever way you are able to learn and get into some good roles. And as a site engineer, also being a structural engineer or knowing structures will help you. Now, whatever offer I gave you, it will have a certification, it will have a 3-year access, it will have a community for discussion, it will have a quiz, assignment, full project explain in it, extra projects and project drawings. Yeah, all you get for 7,999. Yeah, and one extra CAD detailing course. As I told you, this is a bonus. 10 engineers will get it. I told less numbers in the group, but then many people wanted it. So I told them to wait till the announcement comes in the webinar, because this is the only place where I give it off for this pricing. Yeah. Now let's open up for questions. If you have any questions other than what you want to ask here, you can WhatsApp me. And if you want the links and the cheat sheets and all that, you can either put in the group or WhatsApp me. And if you want the course, you can take it from the link I gave you, or you can WhatsApp me as well. And those who want to upgrade, say you have already taken ETABS 1 and completed that and want to upgrade, you can message me. And if you want my DCTS also, you can get back to me on my WhatsApp number. And DCTS, please note that I might not recommend that to everybody. I will speak to you and understand your ability and your willingness to spend time. Then only I will suggest you that. So don't be feel bad about that. If you are really able to spend time, I will ask you. You should be honest in telling me that, and then we can decide if it works for you or not. Okay, so if you are wanting the DCTS program, please message me as well. Now coming to the next part, wait for the challenge. Yeah, before that, let's discuss a few questions that was in the uh, um, group. Okay, so this was asked by Lucas. Yeah, in reinforced concrete structural design for overstress frame member in ETABS, can they be safely designed by simply increasing the reinforcements? See, how and why will ETABS show or any software will show a failure? It will show a failure when uh, it's not able to accommodate that particular member size, right? Say if this beam is shown to have a failure, yeah, that means ETABS is not able to increase the steel. Why? Because there is a limit to the maximum reinforcement. That's when ETABS starts showing a failure. So if it is showing a failure, either column or beam, that means that it doesn't, with the given size, it cannot um, increase the steel further. It has tried its best, maximum. What is the maximum percentage of steel in a beam allowed? 4%. Okay, that's all crossing. So that's the reason it's failing. Now, what is the option? One is increasing the depth. If that is not possible, maybe you have to give a column here. Yeah, whatever. There are seismic when it is there. There are many more aspects, but then I'm just telling you. Yeah, or increase, maybe if the span steel is failing, increase the column size, maybe the deflection will reduce. Yeah, things like that. See if the loads are overestimated. Yeah, things like that you have to do and make it work. Or else the only solution could be increasing the depth. Yeah, so that question is answered. More to it if you want. You will have to do your work and tell me why it is failing, all that more information. Now, this is a question that Narayan Mudli posted in the ETABS community. Okay. How to model sunken slab in ETABS, or how to take care of the same in design. Narayan, are you in the community? If you are here, I will answer it. Are you here, Narayan? Yeah, so I'm answering you. Give me a minute. See, first thing is you should focus on right things also. Yeah. Firstly, you need to think about if that is really, really bothering you, why it should bother you. Say, for example, if your slab is like this, okay, and just drawing. Say you have two slabs like this, and say partially, say you have a cutout like this, or a sunken slab, whatever. Now, why do you, if it's a small thing, 2 meters or 3 meters or whatever, and this is say 3.5 meters, that particular sunken is not going to really matter much. Yeah, it's not going to change a lot of things. So maybe it's an ignorable stuff, rather than trying to find out ways in ETABS to manage that. Rather than that, uh, before that, say if you have modeled this as membrane, anyway it will not be able to, it's not taking care of any continuity or discontinuity of the slab. It's just throwing the load as triangular and trapezoidal. So if your slabs are membrane, even the presence of slab is not accounted. So forget about sunken. Yeah, you are not even accounting the presence of slab in the analysis. For then why do you even think about sunken slab? So that's not relevant if it's modeled as membrane. Now if all the slabs are modeled as shell thin, then maybe yes, this one is slightly, but then if it's a small cutout like this, which generally occurs in a building, it is insignificant. Rather than that, when you design this slab, okay, when you design this particular slab, know that when you are designing the span steel, when you look at the coefficients, treat this edge to be discontinuous, because your idea is that you are conservative. So you should get more steel here in your design. How will you achieve that? By considering this to be discontinuous. While designing the top steel here, yeah, anyway, here it is continuous. So while deciding the top steel here, you need to consider this to be continuous. Yeah, this is how you do it in a normal case. Yeah, so don't think too much. Don't try to be a perfectionist. It's not really needed for a medium project. But having said that, if you want to do it, if it's a cutout, you can of course delete that. And even if it's for checking the slab design, say you are following the shell forces and you are trying to get the forces from ETABS for gravity loads, you can delete one slab and check out the discontinuity. Or if you anyway you want to do it, then you can go here and there is an option only if this is shell. Okay, all these are shells. You can assign shell and edge releases you can adopt. Yeah, so you can um, decide which of the side you need to release, and you can release the edges. Yeah, edge 1, edge 2, all that you need to look at the way you have modeled and understand which edge 1, or this is edge 1, or this is edge 2, or all that you need to understand by looking at the naming and the way you modeled. You started here or started here, all that decides the edge 1, edge 2, and all that stuff. Use that, you try around, you can ask in the community again. Yeah, so I've given you a tip. You can release that using that option. Yeah, but it's not really important for a small structure, if and unless you are doing a very large slab with a very large sunken and you have modeled everything as shell thin and it's bothering you. Otherwise, leave that alone. Okay, more questions you can ask in the community. Anyway, you are in the course group. Yeah, so please use the community further and ask me there after doing this exercise. All right, Naren. Okay. Okay. Now coming to the next question. How to validate column design results from ETABS with manual calculation? See, I will have to say quite a lot of things. John is asking, you are also a course student, I think. John, are you here? You are also an ETABS student. John, are you here? Okay, then I'm not taking it up. It takes quite a lot of time. Validating entirely manual design columns are slightly challenging because of certain nature of the column design. Yeah, if you are bypassing certain real rules like sway index and all that, then you can probably check it by design. But if you are checking designing 100% accurately, it's quite a lot challenging to manually design a column. Yeah, but you can cross check behavior and reaction matching and things like that and ensure that the load takedown in the columns are all fine. Yeah, rest of it you need to leave it to the tool. You can take some minimal moment capacity and check for the axial load and things like that. Yeah, so uh, it's all explained in the program in the course. You are anyway a course student, so you can see it in the program. It takes quite a lot of time to explain that. Now next question. 1 second. I think Ayush he's also a course student. AST values in ETABS for beams does not follow any pattern like descending from bottom to top, which normally should be. So should we not do? I'm not understanding this question, Ayush. So you need to tell me. So are you here now, Ayush? I had asked you to come in the live class. Ayush, are you here? I think he is not there. So let me just answer it. If my understanding is correct, I'm not able to understand that. Say, when you have a structure like this, and if you are doing for seismic, generally, if you are not doing for seismic, only dead load, live load, you all know that column lower level will have more load. This will have, it keeps on decreasing as you go up, and you will have more steel in the mostly, yeah. But moment also has certain moment and forces interact, so there will be changes. But then it's likely that your lower level can have more steel requirement. But when there is lateral, it can be in different ways based on the frame action. Yeah, you may get more steel here, less steel here, again more. All that can happen. Now coming to the beams, generally, yeah, your uh, lower level beams are likely to have more forces. Yeah, as you go up, it might be reducing. I don't know what exactly you are asking. Yeah, so you cannot do it like um, all the floors same steel in beams. If it's a very high floor building, yeah, it will change, especially in the last level or pre-last level and all that. Your beam steels are going to be much lesser. Yeah, so you will have to detail it out for all the levels. Yeah, or at least group 2 levels each. You need to look at the pattern, look at your particular scheme, and then decide if you can group multiple floors together. Yeah, but definitely all the floors you cannot give the same steel. You will be very much uneconomic if you are going with the conservative approach. Yeah, or else you will be unsafe if you are going with the other way. So I didn't exactly understand your question. If you clarify it, I would be happy to answer. Now you can post it again with more clarity in the community. He is asking about shear wall boundary element. Is it needed or not? Yes, it is needed. Nowadays, most of the firms are just providing uniform reinforcement. So it is better. It depends again on the size of your project and all that. It is better to provide boundary elements, because if you look at the shear wall, that's how it is going to behave. It will have corner stresses. Now, this is a challenge that I'm giving you, especially this is not really for my students who have taken the paid programs, because this is something which you might be able to easily answer because you have taken my program. Yeah, but then this is for others. You can try this challenge that I'm going to give you. And if you meet my expectations, and the best one would get a reward. What the reward is, I will tell you if that is met with an expected answer. Yeah, so I will tell you the question. So everybody can participate, but then my students, I will decide if I should give you the reward based on what the answer I see. Okay. If it's exceptionally good, my students will get this challenge reward. Others, I open this for you. Okay. So now here it is. Very simple one. Yeah, I'm primarily looking at uh, beginners to starters, that range people, so that you are motivated to learn. Yeah, very experienced people may be able to easily answer this, but still, if you want to try, you can do that, no problems. Okay, so this is the challenge. Say the client requirement. If you have more questions, okay, I always say engineers should ask questions. So if you have more questions, this may be a partial data. I'm not revealing anything right now. If you want more data, ask. You come in the group, ask. Okay, so that's how it is going to be taken up from here. So the data I'm giving you right now, assume that I'm your client. Location, I'm from Delhi, New Delhi. Soil report, I am not done, but then one of my friend had done a recent project. This is the data that I'm giving you. I am the client. Okay. Soil N value is 20 in the other project which was done nearby, very nearby. Yeah, same compound wall, one building the other way. Soil N value is 20. And dimension of this project is 15 meters by 60 meters. Okay. And I want a precast, something like this. Yeah. You can see this. Um, it's a slotted connection. You have a recess in the column. I'm placing I want to do it like this. I've seen such buildings in US. Okay. So I want to have this seated in this particular slot and I want to build it. And I'm open to structurally have the best solution. Okay. Anything as per the code, open to do things. 15 meter by 60 meter and value is 20. Location is New Delhi. Please give me a solution. Okay, so scheme it, sketch it, the best in terms of representation, in terms of communication, in terms of solution. So three things are going to be looked into. Solution. Yeah, I don't want exact dimensions and all that. If you have time and if you want to do it, all that is fine. But I'm looking at the best solution, best presentation, best logic, all that, all that. Yeah, everything together, which is the best. And if many people submitted, and if all the answers, all the solutions, and all the things submitted are not up to a certain standard, I won't be rewarding you. Yeah, but if there are many who are having a great representation and great solution, then the best, in my opinion, will be given a reward. What it is, we'll discuss in the next uh, talk. Yeah, next class. So that's it from me. So if you have any questions, I will open up for a quick discussion. We are short of time, but then let us open up for more. Uh, Give me a minute. I think. Yeah, so you can pick up your mic and quickly ask your questions. I will take a few questions. Tell me if you have any questions. Anybody? Arun is asking, is it practically viable in Indian condition to apply cracked section? Yes, it is viable. You have to do it. Yeah. Your scheme will become more robust. Yeah. So that's something which happens. So it's not about Indian conditions. Everywhere cracked section should be taken. Narayan is asking how to assume the SBC of soil. You cannot assume. Yeah, you need to get the right one. Parikshit is asking how to get structural engineering internship. See, MNCs will have a policy. So generally they take from, say if you look at companies like Atkins, they will take only from uh, NITs and really good colleges. So if you are from a really good college, you can try. Yeah, they give campus drives also. You can try with them. Yeah, generally, otherwise it's very difficult to get any internship. Yeah, and again, it should be a long internship. Now companies are looking at their benefit also. Yeah, as a corporate responsibility, a few companies might be doing it, but not many. Any questions? You can pick up your mic. I've given you the uh, mic. Parikshit is asking what DCT is basically about. It's my mentoring program where you have 6 months of live classes, a lot of things. Yeah, if you are keen, you can send me a message. I will share you a video which will help you to understand what that is all about. If you want, I will also share the link. You can see this. etabs.civilerra.com. In that, there is a video. That video will explain you what it is all about. Okay, Parikshit? Anybody else also want, you can either message me or you can see that particular link, etabs.civilerra.com. Yeah, in that you will get a video that will explain you what my mentoring, what it covers and everything about that. Any other questions? Please feel free to ask. Nothing?
Sir, it's me, Pawan.
Yes, tell me, Pavan.
Sir, I have a small doubt that after designing a structure in ETABS, we'll be checking the column area of steel, right, sir? Uh, as per code, the maximum area of steel allowed is like 4%, right, sir?
Yeah.
But in ETABS, it will be giving for maximum of 6% after greater than 6%, the column usually fails, sir. But as per code,
Yes.
4% is given. And can we follow 6%, sir, as well? Like in practical point of view, 6% area of steel can be provided in column.
No, even 4% is high. Yeah, you will have congestion. In normal, smaller projects I'm talking about, it'll be high congestion. So I would keep, say, 3.5. See, the thing is, 6% ETABS might be showing because as per the code, if you are not lapping, that is the maximum. Okay, 4% is a rule that code tells you it's good to keep 4% if you are lapping the rebars because the lapping zones will create congestion. Yeah, so you need to reduce that to 4%. ETABS might give more, so you bring it down.
So like there is any option, sir, to restrict it to 4% in ETABS?
No, you can do that. No, you can play around and you can see in elevation and you can reduce it.
Yeah, sir. We can reduce it after checking, but while designing itself can be like minimum percentage, it is fixed to
No,
0.8%, right? Like,
no, you can do this. You can keep
like manually check
for,
and
you can do the check instead of
uh,
doing the see, when you are defining the section, say those columns you can pick and see whichever is having more, those columns you can, instead of performing the design option, this is beams, in columns also you can do the same. Instead of using the design option, reinforcement to be designed, you can go with um, the checking option. Let me take. It's taking a little time. Yeah, instead of this, you can do this and keep your required percentage here, and whatever is failing, you will be able to see that. Yeah. So,
okay,
so whatever is failing needs more than that. Whatever is passing is having lesser than that. So you group those columns and manage it. Yeah. So that
okay,
is the best way I can right now think of.
okay, thank you.
Yeah. Any other question? Anybody? No?
Sir, Narayan is.
Yeah. Tell me.
Okay. Sir, how to check my ETAB model is correct or wrong?
See, this is a very broad question. How will I tell you if ETABS model is correct or not? There are so many checks required. Yeah. So in the course I have explained, you need to keep three kinds of checks in your in any project. It's not just for ETABS model alone. For anything, you need to have three kinds of check in your process. Yeah. What is that? One is software based. Yeah. So what is software based check? You have this analyze check model. Yeah, give the tolerance, select all this, click on OK. So this will do certain kinds of check, correct? That is one check, software check. All right. So if there is error, it will show there is error. If there is no error, it will say there is no error. So this is one kind of check that you need to adopt. That's a software check. All right. Then you also need to inspect. Okay. See, I showed you that deflection. Say, analysis will take some time. Let me analyze it. I will show you. Let that analysis occur there. Till then, we'll speak something else. Second check is behavior based, as in, are you getting the expected behavior? Cantilevers behaving as cantilever, simply supported beams behaving as simply supported beams, continuous beams behaving as continuous beam, bending moment pattern, deflection pattern. All this you need to go and check and ensure fairly it is behaving. Thirdly, you need to have a process check. Okay, what do you mean by that? Your model checked by your senior. Your model may be checked by a peer. Yeah, your model, you self-checking it for every aspect of it. So in all these process, you develop a checklist for you. Okay, definition, load calculation, whatever. Wherever you are making more mistakes, that should be having more priority in your checklist. So develop that. Okay. So ensure that once you have done that, you check this, because this is something which you are always making a mistake. Somebody might forget to assign a support. Check that. All this, every process you include as a checklist, ensure that after you do it, everything is checked. Yeah, that's a process checklist. Then your team member checking it. If your company has multi teams, maybe another team checking that. Your senior checking and validating. Yeah, all this should be implemented as a process. So don't expect everything to be manually checked and verified. You will die doing one project. Yeah, everything cannot be manually. See, do you think that a 20-floor building, not even 20-floor building, in the current situation, depending upon the project situation, the demand, do you think that every project can be manually designed? And analysis, is it even possible? How many load combinations you have for designing a column? Yeah, so you can only do certain checks. Yeah, maybe ensure that there is no gross error. Yeah, so you need to rely on all these. It's not just everything manually checking. It's impossible. Yeah, so you need to wisely use these software checks, behavior checks, and you need to have process included. That's why very large projects are proof checked by other consultants. It is made mandatory in India now. Yeah, so the BIS itself tells you that it should be peer reviewed. If you go to Middle East, okay, and UK, there are building regulators who will also check your designs. If not everything, they will have their own. They would have had a checklist like this. They will decide what needs to be checked. Yeah, and they will approve, and then only it will be allowed to be built. Okay, so that's how you need to develop. It's a multiple thing. It's not just one thing. Yeah, I cannot give you one answer for that. Okay, now let me also tell you, in order to ensure you have less number of um, checks, maybe you can go and do this. One second, let it animate. So if you have any disjointed members, you will be able to see some things fluttering. Yeah, so if something is not connected and all that, maybe it will flutter and you will be able to, the deflections will be very large. So seeing this behavior, you should be able to find out if your model is okay or not. Yeah, so a lot of things you can capture in by adopting these practices. Yeah, so you need to employ all this. Agree?
Thank you, sir.
Yeah. Parth is asking how is considered crack section even after. See, factor of safety is something else, cracked section is something else. They are for two different things. Yeah, any other questions? Okay, so we are almost hitting the last minute.
Hello,
Yeah.
sir.
Yeah.
Hello, sir. If the
Yeah.
beam depth is increased, it will it take the uneven settlement in plinth beams. If the plinth beam depth is increased, uneven settlement in soil, will it take, sir?
No, see, beam depth is related to what? Is it a ground bearing beam? Is it a frame beam? Yeah, you
Yes.
have to tell me all that. if it is connected
Okay.
to the columns,
Yes, sir.
then you are required to give the required depth, right? Not more, not
Okay.
less. Yeah. So if you have a beam, then your load is not going on to the lower level, right? It's only when you are deflecting. See, if this is your plane beam, okay, and say here you have soil,
Okay.
only if the beam settles more than permissible, it's going to transfer anything here and settle, right?
Okay.
Or if it is ground bearing, then only it is going to settle, right? And if it's ground bearing, yeah, it's not connected to columns. And if it's ground bearing,
No, actually, the column is going to settle. No, will it? Will the beam will
okay,
take care of the
okay,
column settlement?
okay, got it. Yeah. So if you are talking about the foundation settlement,
Yes, sir. Yes, sir.
see, this connecting the columns are going to reduce the differential settlement because they are rigidly connected. Yeah. So it will act as a single unit.
Yes.
Yeah. So the chances of differential settlement is less. Yeah. So more depth to the beam will make it more rigid, and it will act as there are more chances of it acting as a single body. Yeah. Rigid
Okay.
body. So the settlement can reduce if the beams are deeper.
Okay.
Yeah. But then if you look at, see, all these are precautions. You should not rely on that and reduce your footing size. Yeah. So you need to design it for the SBC that you know. You need to do all the number of boreholes and all that as per the requirement. And after all this, you can give connection. I mean, you are connecting it with plane beam for extra avoiding the settlement. Yeah. So if you take care of all this, there will be no problem. Okay.
Okay, sir. Sir, what is the single curvature and double curvature in column?
Yeah. So that is based on the frame behavior. Yeah. So if it is in single curvature, you will be able to pick it from the way it is bending. Yeah. Double curvature means it is having a curvature of double curvature. How do I explain? It is double curvature. So you are talking about the way you are adding the additional moments, maybe, right? As per IS 456, the
Yes,
slenderness
sir.
moments and all that.
Yes, sir.
Yeah. So you can leave that if you are designing using ETABS. ETABS, instead of looking at the addition and the two methods given in IS 456, it will design for multiple sections. So it is automatically covered. That particular equation in IS 456 is given in order to ensure that you are doing it conservatively. Yeah, but then if you are using ETABS for designing, one member itself, it is designing at 3 different sections. Yeah, you can increase the numbers by changing the setting, but then since it is designing at various locations, you don't have to add like that equation. Yeah, ETABS is internally taking care of that. It's a thumb rule, in fact, to capture the maximum. Who asked this? Yoganand, is it? Who was
Yes,
that?
sir. Yes, sir.
You had taken my program?
Not fully covered, sir. I'm going through, but not fully covered it, sir.
Okay, in that it's there.
Okay. Okay, sir.
Okay. All right. So let's wind up for the day and catch up in the next program. So till then, if you have anything, keep posting in the group. Good ones, I will pick it in the class, in the next class, and discuss. Okay. All right. So great speaking to all of you. Have a good night. Yeah. So see you soon tomorrow. Tomorrow in the group, and next week or next to next week in the webinar. All right. Good night.